Please tell me if I am an absolute idiot for asking this question, okay? Please tell me. I know the answer, yes, but please tell me whether or not I am. Okay, I think this is an interesting question you can ask your friends, and I'm gonna tell you my interpretation of it. So, the question is, could your red be my blue? What I'm essentially asking here is, do we perceive color as the same? Right? So, if you think about it, can you really describe your color? Describe green to me. Yeah, didn't think so. How? You can point at a tree, you can point at some grass, but at the end of the day, you can't, quote unquote, describe it to me. Right? It's not like you can describe a keyboard. Okay, that's straight edges, and a bit is curved. No, not a keyboard, sorry. Or like a, I don't know where I'm going with this. Let's say a wallet, right? You can say, oh, it's got straight edges, and then it's got a curve. Okay, I understand what you're saying, but you can't describe a color, can you? So, could your red be my blue? This is something you can ask to people, and a lot of people will say, yes, it can. But I'll give you my interpretation of it, so that when you do ask this to your friends, you can seem like the smart one in the room, because, I often think about questions that nobody in the world has, enough time or who actually wants to think of these questions. So here's what I think. If we analyze this more deeply, right? So if you have taken any science class, then you know there's something called the EM spectrum. All right, I don't like to use the word spectrum these days because it can mean a lot of things. Some are much more interesting than others, but anyhow, going off topic here. But the EM spectrum, there's a bunch of stuff here, all right, bunch of different crazy physics stuff, and this is visible light. So invisible light, which is the only light we can see, right? We can't see infrared light, which is heat. We can't see heat. We can feel heat. We can't see it. Mosquitoes can see it, as well as other animals. But in any case, visible light itself is separated into a spectrum. And the spectrum is divided into the different colors, roughly, right? So the frequency increases this way. And then you get the classic rainbow. So that'd be Roy G. Biv. Figure that out for yourself. Alright, I assume you're smart if you're watching this video. I assume all my viewers are smart, by the way. Thanks for the comments. If you commented and if you liked or disliked, which is fair enough. Thank you for that. But in any case, some people make the argument, right, that yes, in fact, your red can be my blue because the wavelengths of light are always the same. We can identify a wavelength of red, right? It's, X frequency. And then for green, it's Y frequency. And it's always that way. True. You're not wrong. But then we have to ask the fundamental question. How do we perceive color? Let me give you an example, right? This is actually very interesting. One of the fundamental questions of vision itself, I've read some neuroscience books on this, by the way, is luminance versus lightness. Believe me, this is relevant. And you can talk about this, right? So, what is the difference? You can think about that for a second. Okay, never mind. Scrap that. So, luminance is something that can be defined in units. Usually it's candelas and something like that, all right? It can be described in units. You can get a machine that detects how much light is in the room according to this. But what is lightness? Lightness is your subjective perception of light. And that is entirely due to the composition of your brain. That's it. It's your neurons. So why can't this principle be applied here as well? The luminance is the same, but then lightness is different for different people. So that means that although the frequency of a red is the same for you, you perceive it as something else. It's like color, and then you have brain color. These are different. The color red, okay, it's X frequency. The color is X frequency, but your brain color is something. And this something could be different for different people. Maybe this is the something for you. This is the something for me. So in that case, since our brain color can be different, that means that technically your red, your perceived red, the brain color red, could be my brain color blue. Isn't that crazy? It's kind of trippy when you think about it, right? And just so you know, if people say, well, why can we all tell the same? Why do we call all the colors the same? Like, why do we both think that a certain color is red, right? Like, what I mean by that is, some people say, okay, but we still call the same things red, we still call the same things green, so if we perceived it differently, wouldn't we call them different names? Well, I think a lot of that is just what the colors are relative to each other. Because at the end of the day, they are different wavelengths, so they'll have a relative difference in both color and brain color. But then, at the end of the day, the absolute brain color, which is what you actually perceive it as, that can be completely different for everybody. So, can your red be my blue? I think so, but please comment below if you have a different opinion, and ask this to your friends, because I'm very curious about their opinions as well. Alright, goodbye.